Unit 3.2.2, that is design of the solar PV system in the solar PV installation course. So this is almost the practical application of the previous units which we have covered in the same course. Or we can say whatever we have just studied about the solar PV system. In this unit, we have to study about its installation. Okay, so design of the solar PV system that begins with the components. Okay, so each household has different electrical equipment leading to different requirement of electric supply. Means we have to consider the load, how much load that is being supplied by the system. The installation technician should take care of these varying requirements while designing solar PV system. The requirements, they are not constant. Load that can change. It could be higher sometime, it could be lower. Yes, each solar PV system is custom designed to meet the requirement of the customer. The design of solar PV system requires calculation of the values of different components. So what were the components which we have discussed in a solar PV system? So first one, that was solar modules, the solar panels, then the battery, considering the standalone or grid connected with battery backup, this type of system. Okay, so battery is another component. Then charge controller and inverter. Inverter when we consider our load to be AC. Required to make the complete PV system which is capable of supplying electricity to the connected load as required. So the steps involved here in the designing of a PV system. The first step is estimate the amount of electricity required by the load. Means we have to initiate from the load. You have to calculate the load or the requirement of electricity. How much electricity is required? What is the consumption? It is, if we are installing it in a house, then what is the consumption inside the house? How much electricity is consumed? What are the different equipments which are being which are to be run on electricity, to operate on electricity? Okay, next step is determine the capacity and size of various components. Okay, then as per the load, we will determine the capacity and size of our components in the PV system. So following information which is required to design a solar PV system. So first one is the location of installation. We should have complete information about the location where we have to install the system. Next is amount of sunlight available. So how much sunlight is available there? That determines how much electricity we will be getting. What is high, we also install a larger sized system PV panels. Okay, we can install. But what if it is not getting sufficient sunlight? Okay, then number of loads to be connected. How much load is to be connected? The number of hours of usage for each load. High power load, low power load, different type of equipments, they are placed inside the house where we have to install the this solar system, PV system. So for how much duration, the different type of equipments or the load inside the house that is being operated, that determines the total energy consumption. Okay, then availability of components in the market. Also we have to check that is components are available there in the market. Components we want for our solar PV system. It is not available, then very difficult to install the solar panel system. Or if we have to make arrangement from very far location, that will also be not easy. So we have to prefer which the components which are available in the market or which we can easily procure. Then rating of the components, that how much rating kilowatt of solar panels, how much ampere hour of the battery, What are the kilowatt or kVA rating of the inverter, charge controller? Okay, so rating of the different components after that. So these are the steps how we have to design our solar PV system. The design can be of two types. First of all, approximate design, and second is precise design. Okay, so there are many factors, many parameters which affect the solar PV system. Sunlight, amount of sunlight, that is also not constant. For how much time we are getting sufficient amount of sunlight. So these type of parameters that affect the electricity generated by the solar PV system. So they are changing, sunlight that is changing, load is also changing. Because what is suitable in that case, that we create an approximate design. Exact design we are finding difficulties because of the variation of the parameters. So the approximate design may not be 100% according as per the load, may not be totally rated designed as per the load requirement, but it is approximate, means almost. Okay, not exact but almost. It will satisfy the load requirements. So it is more suitable for small systems. For large system, we prefer precise design. So like a household, common household, a load, that is what we can, it can work on approximate design. But in case of 100 of kilowatt, 100 kilowatt plant, okay, 1-2 kilowatt small size load, that is okay for approximate. But if 100 kilowatt load is there, or the 100 kilowatt system we have to design with a capacity of 100 kilowatt or more, 200, 300, then precise design will be preferred. So we have to consider, in that case, we have to consider all of the parameters. Average sunshine hour we have to find for that location. Okay, so as per the size of the load, rating of the load, we can opt for approximate or the precise design. Now, approximate design of a solar photovoltaic system. So some of the temperature parameters we can neglect, like temperature. Okay, because we studied that when temperature increases, then the electricity production that decreases. So this is one parameter affecting the output from the solar PV system. Okay, radiation, okay, we have discussed these things in detail. So these parameters may impact the production, electricity production from the system. Okay, but for approximate design, we can almost neglect these parameters for small scale, we can say. There we are using approximate design. Okay, so energy flow diagram, that is useful in designing the solar PV system. So during sunshine hours, energy flows from the PV source to the battery through electronic circuit. Okay, through the power converter. So what are these electronic circuits? Here it is shown in the diagram. This is the energy flow diagram. So PV array, from there is a charge controller. We have discussed all of these components in detail, why they are used in the previous units. Okay, so through that, to extract the maximum power, we use the technique of maximum power point tracking. Okay, so charge controller, that is electronic device. It can detect. Okay, inverter, that is also a power electronic device. Okay, so maximum power that is to be extracted by using this charge controller that can adjust the operating point on the curve, the power curve of the solar panel, which we have studied. Okay, so when the load is operating, energy flows from the battery to the load through the electronic circuitry. Okay, in case of AC, load is AC, then inverter is also needed. If our load is DC, in that case, we don't need inverter. directly we are getting the DC from the panel, we are storing it in the battery, that is also DC. So directly we can connect the load with that battery. Okay, so through the charge controller, okay, which makes the output available from the battery that's suitable to the DC load. It also makes the output from the PV array suitable for the charging the battery. So load, it is not directly connected with the PV array, it is connected through the battery. And from there we are feeding the load. Okay, so in the diagram, we saw power flow from the panel to the charge controller to the battery to the load. Through the inverter also in case of AC load. Now to design of a PV standalone PV system, there we need a battery. Yeah. Okay, so that is exact in the reverse of the power flow. Designing process is in the reverse. So as we move from the PV panel to the load, in case of energy flow, in case of designing, we will move from load to the PV panel in the reverse direction. So how we can see in these steps. So determine the connected load and their energy estimation. Means first begin with the load. Energy flow diagram, we begin with the PV panel, solar panels. Now in case of designing, in the reverse we will move. So first we have to determine the load. How much watt hour means power and energy, that we have to determine. Okay, that is the connected load. What is the connected load? Okay, remember the first unit initially which we started. Every component which is placed, equipment, if it is a house, then household devices, fan, kitchen appliances, okay, tube lights, different lights, all of them, they are load. So we have to determine the total power consumption by the each component, then add it. Similarly, the time for which they are operated. Multiply the power with the time, the kilowatt rating with the time, or the watt with the time, that will give the energy. So that is the connected load and their energy estimation. The next step, determine the size and choice of electronic components. So which type of parameters? The power rating, voltage, current at input and output. So these parameters we have to determine for the power electronic components. Okay, so inverter, okay, we can decide in this way. Charge controller, okay, we can decide in this way. What should be the power rating for how much kilowatt or kVA? Okay, how much voltage, how much current? Should be the capacity of the power electronic device should be so as to be suitable for that load which we are having the load. Then next thing, determine the battery size. How much ampere hour, the capacity of the battery, how much ampere hour battery will be suitable for that. One battery may be not sufficient, so we need more than one battery, two. Okay, so the number, capacity, voltage, and ampere hour ratings. Then after that, move towards the PV module. What should be the size of the PV module? The solar panels of how much kilowatt, how much voltage, how much current. Okay, how we can calculate or make it suitable as per our requirement? By making the series parallel combination. Yeah. So last thing is determine the size of wires in fuse, in ampere, and junction box, volt ampere. So these are the connecting components, miscellaneous components, we can say. Wires, fuse, junction box. Okay, larger the current, then thicker the wire. Larger the rating of the fuse, junction box. For low current, lesser diameter of the wire, so less